Good evening all. We shall continue with our third module. Here we shall see types of conductors used for transmission. A conductor is one of the most important components of overhead lines. Selecting a proper type of conductor for overhead lines is as important as selecting economic conductor size and economic transmission voltage. So the purpose of conductor is to transport power from one location to other, subjected to certain conditions. A good conductor should have the following properties. It should have high electrical conductivity, then high tensile strength in order to withstand the mechanical stresses, relatively lower cost without compromising much of its properties, lower weight per unit volume, then the conductor materials that we use commonly in power engineering purpose. Copper. Copper has the highest conductivity and greater tensile strength among the conductor materials that we are using. So copper in hard drawn standard form is a great option for overhead lines. Copper has a high current density, which means more current carrying capacity per unit cross-sectional area. Therefore, copper conductors have relatively smaller cross-sectional area in order to carry the same current compared to other metals. Copper is durable and has high scrap value. However, due to its higher cost and non-availability, copper is rarely used for overhead power lines. Next, aluminium. Aluminium has about 60% of the conductivity as that of copper. For the same resistance, the diameter of an aluminium conductor is about 1.26 times that of a copper conductor. But an aluminium conductor has almost half the weight of an equivalent copper conductor. That is an advantage. Also, tensile strength of aluminium is less than that of copper. Considering combined factors of cost, conductivity, tensile strength, weight, etc., aluminium has advantages over copper because it is cheap. Therefore, aluminium is being widely used for overhead conductors. Then, cadmium copper alloy. They contain approximately 98 to 99% of copper and up to 1.5% of cadmium. Addition of about 1% of cadmium to copper increases the tensile strength by up to 50% and the conductivity is reduced only by about 15%. Therefore, cadmium copper conductors can be useful for exceptionally long spans. However, due to high cost of cadmium, such conductors may be uneconomical in many cases. Other materials used are, there are many other metals and alloys that conduct electricity. Silver is more conductive than copper, but due to its high cost, it is not practical in most of the cases. Galvanized steel may also be used as a conductor. Although steel has very high tensile strength, steel conductors are not suitable for transmitting power efficiently due to the poor conductivity and high resistance of steel. High strength alloys such as phosphor bronze may also be used sometimes at extreme conditions. Then some other types are AAC, aluminum all aluminum conductor. This type is sometimes also referred as ASC, aluminum stranded conductor. It is made up of strands of electrical conductor grade aluminum. AAC conductor has conductivity above 61% of international annealed copper standard. Despite having a good conductivity, because of its relatively poor strength and more sag per span length than any other category, AAC has limited use in transmission and rural distribution lines. However, AAC can be seen in urban areas for distribution where spans are usually short, but higher conductivity is required. AAAC, all aluminum alloy conductor. These conductors are made from aluminum alloy 6201, which is a high strength aluminum magnesium silicon alloy. This alloy conductor offers good electrical conductivity, about 52.5% of IACS, with better mechanical strength. Because of AAACs are lighter weight as compared to ACSR of equal strength and current capacity, AAC may be used for distribution purpose. However, it is not usually preferred for transmission. The presence of formation of alloy makes it quite expensive. Also, these conductors can be employed in coastal areas because of their excellent corrosion resistance. And ACSR, aluminum conductor, steel reinforced. This is the most popular material composition used for transmission. ACSR consists of a solid or stranded steel core with one or more layers of high purity aluminum wires wrapped in spiral. The core wires may be zinc coated, that means galvanized steel, or aluminum coated, that is aluminized steel. Galvanization or aluminization coatings are thin and are applied to protect the steel from corrosion. So, aluminum strands are provided over steel strands. Steel is used for providing more strength to the conductors. The central steel core provides additional mechanical strength and hence sag is significantly less than all other aluminum conductors. ACSR conductors are available in wide range of steel content. Steel content can be from 6% to 40%. ACSR with higher steel content is selected where higher mechanical strength is required, such as river crossing. ACSR conductors are very widely used for all transmission and distribution purposes. These types of conductors are of much use for long spans of transmission lines because these lines got high tensile strength. AACSR, aluminum alloy conductor steel reinforced. They consist of high mechanical strength, high tensile galvanized steel core covered with aluminum alloy wires. This type of conductors can be used for any rough mechanical circumstances. So these are the general types of materials and compositions used for transmission purpose. Next class we shall study about supports, and thank you very much for listening.